Hey guys, today we are going to discuss about chapter 1.2 set notation and Venn diagrams. At the end of this lesson, you should be able to use language, notation and Venn diagrams to describe sets and represent relationships between the sets. And you should be able to define the sets. So what is sets? Set is a well-defined group of elements. It's a group of elements. Later we're going to discuss more about it. Normally this for set we'll write the letter as a capital letter. For example, set A will say set A. For example, for set B we'll call it as set B in capital letter. Okay. So let's say inside it has elements. The objects inside the set is called elements. For elements, we write as small letter. For example, for element called A, we write as A, small letter. For B, we write B. So if let's say I say if an element E belongs to a set S, we'll write it as the element E, small letter, is an element. We'll denote as this. Is a element of the set S. We write as capital letter, and this simple is means is an element of. This means it's an element of. Alright, let's say E is not an element of S. We write as E is not an element of set S. This means it's not an element of. You get the idea. For example, we have these 4 questions. Question 1. A particular set consists of the following elements. We have Thailand, India, Indonesia, Malaysia. So the first question asks us, describe the set. You can say this set, you can say the elements of the sets are countries of Asia. Right, because Thailand, India, Indonesia, Malaysia, these are elements, and this whole thing consider one set, and this set, so the elements of the set are countries of Asia. Question number 2. Add another 2 elements to the set. Or you can add maybe Singapore, maybe China. Question number 3. Is this set finite or infinite? When we talk about finite, means there is a limited number. Infinite means there's infinite answers. So is this set infinite? Yes. This set is finite because there are finite number of countries in there are finite number of countries in Asia. I just don't write. Question number 2. Consider a set A where x, this x is a natural number. Describe the set. You can say the elements of the set are natural number. Write down 2 elements of the set. Maybe any natural number, maybe 4 and maybe 16, whatever. As long as the answer you wrote is a natural number, then it's correct. Question number 3. Consider set B where xy where y is equal to 3x plus 2. Describe the set. So what does this mean? This means that whatever x and y are, you must fulfill this equation as long as what x and y are. So the elements of this set B are the coordinates of points found on the straight line with equation y equals to 3x plus 2. Write down two elements of the set, so you can add any value as long as it's fulfilling this equation. So maybe x is equal to 0, when x is equal to 0, 0 plus 2, y is 2. So you can write x is 0, y is 2. And maybe when x is 1, 1 times 3 is 3 plus 2 is 5. So these are the two elements of the set B. Question number 4. Consider the set C where x was between this range. Describe the set. This means that the elements of the set include any number between 3 and 7 inclusive. Write down two elements of the set. Maybe 4, maybe 6.5. It's in the range, so it's considered as the element of the set C. Now we are coming to subsets. If all the elements of one set, maybe set X, are also elements of another set Y, therefore we say that X is a subset of Y, and we denote subset as this symbol, like a C with a dashed line in the bottom, at the bottom of the C. So yeah. So if set A is empty, we call it as empty set. So we denote empty set as this little circle with a slash. This is called empty set. And take note, empty set is a subset of all sets, whatever it is. So for example, we look at this. Set A contains Jack, Mary, and Peter. Set B also contains Jack, we denote as J, Mary denote as M, Peter denote as P. C contains this Jack and Mary. Set D contains J and Peter. Set E contains Jack. F contains Mary. G contains Peter. H means empty set. So take note that for the set B and the set H is considered as a subset of A. So we can say that B is a subset of A, and H is a subset of A because empty set, right, is a subset of all sets. Whatever it is always a subset of all sets. However, for set C to set G, these are considered as proper subsets of A. It's called proper subset. Proper subset, and we denote it as just the C without the dash line at the bottom, unlike this one. This one has a dash line, but this one doesn't have the dash line. So yeah, so for set C to set G, these are considered proper subset. These are the proper subset of set A. these are the distinction between subset, proper subset and subset. And let's say if we say that G is not a subset of H, we can say G is not a subset of H. If we say G is not a proper subset of H, we can say G is not a proper subset of H. Something like that. So for example, this question, set A, it contains these elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. List subset B, even number. It means that B, the elements of B is what? That means they want in even numbers. There is subset from this set A, which are 2, 4, 6, 8, and 10. These are the only 5 numbers that are even number of subset A. Question number 2, list subset C, where C is the subset prime number of A. That means C is only 2, 3, 5, and 7. So let me ask you another question. When we write this symbol, it means, you can see from here, subset of n, in this symbol it means number of elements in set A. So in this case, number of elements in set A, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's equals to 10. And the number of elements in set B is equals to 1, 2, 3, 4, 5. There are 5 elements in set B. And the number of elements in set C is actually 1, 2, 3, 4. There are 4 elements in set C. When we come to universal set, universal set is denoted as this like something like looks like E, or you can look at here. This is from the syllabus. Something looks like this. Universal set means the set in which it contains all the possible elements. So another thing, complement. When we talk about complement of a set, maybe complement of set A, we write it as this A prime with an apostrophe here. So complement of set A means the set of elements which are in the universal set but not in A. That means the elements that are not in A is complement of A, but the elements must be in universal set lah. So take note this. Complement of universal set is actually equals to empty set, and complement of empty set is the universal set. For example, we look at this question. If universal set is contain this and set A contain this, what is the complement of set A? So complement of set A means the set of elements which are not in A but is in universal set, which are, because here contains 1, 2, 3, 4, 5, the elements which are not in A is A prime, which is 6 to 10, 6, 7, 8, 9, 10. That's all for complement and the universal set. Now we come to Venn diagram. Venn diagrams is a principal way of showing the sets dramatically. So the method consists of primarily of entering the elements of a set into a circle or circles. So for example, we look at this. Set A consists of 2, 4, 6, 8, and 10. We can represent it in a circle, and outside of the circle we denote as a letter, set A. And inside the circle we write the elements of the set, which are 2, 4, 6, 8, and 10. So elements which are in more than one set, can also be represented using a Venn diagram. For example, look at this. When we look at this, set P consists of 3, 6, 9, 12, 15, 18. So we look at this P, this circle. It contains all the set elements inside the set P. And in set Q is 2, 4, 6, and 10, 12. We look at this, also contains 2, 4, 6, 8, 10, 12. But then between them, there are intersections that are in common, which are 6 and 12. 6 and 12. These two are the intersection. So when two sets P and Q overlap, as they do in this case, the notation P is something like N. It looks like N. We call it as intersection. P intersect with Q with this one is equals to, in this case, is 6 and 12. So take note that 6 is actually an element of P intersect with Q. However, 8 is not an element of P intersect with Q, because inside, between here, there is only 6 and 12. There is no 8. It is at Q, set Q only. Okay, look at this one. Set J, it consists of 10 to 100. K consists of 60 to 60, 70, and 80. So in this case, we can say that K is a proper subset of J, right? So in dramatically, we can draw it in this way in Venn diagram, because 60, 70, and 80 also in 60, 70, 80 also in set J. So we can draw like this way. For this one, set X contains this, set Y contains this. So when we talk about the whole thing, we call it union. And union of two sets is everything which belongs to either or both sets, and is represented by the symbol U. Looks like U, but it's not U lah. So in this example, X union Y is all the elements inside here, which are 1, 3, 6, 7, 9, 13, 14, and 18. That's all about this chapter.